Again, we're going to continue looking at how to use the technology, specifically Minitab, as it relates to quantitative data. Again, at the beginning of this particular grouping of lessons or module, we've looked at the measures of center, measures of variation, and measures of position. We talked about all the differences between those. How you could manually calculate those. But honestly, again, in most cases when conducting research, you're going to be using some form of technology to perform those calculations, especially if you have, 500, 5,000, 50,000 data values. You do not want to be doing that particular type of thing by hand. So I've continued to use the example that we've been looking at throughout these lessons. And our research question is, what is the average age in years of students taking classes on the GHC Cartersville campus in spring 2018? And you have your raw data set. It does indicate for us that we have 50 data values. That's our sample size N. The minimum is 17 and the maximum is 54. So initially we would have to take that raw data and enter it into Minitab or to whatever statistical software we're using, because remember, you can't really do anything unless you have the data. So I've actually already entered that into Minitab for us. The process that you go through, again, it's very intuitive, but I do have the process typed out here for you on this particular slide. And then on the next slide, I provide you with kind of a screenshot of selecting the descriptive statistics that you want Minitab to calculate, and then also the results. But I want to walk you through it in Minitab. Again, it's very intuitive. So we've entered our data, again, labeling it ages and years. And we want to find the descriptive statistics. So I'm going up to the main menu bar and I'm going to choose Stat. And I want to do just basic statistics. And then I want to display the descriptive statistics. Okay, so Stat, basic statistics, display descriptive statistics. And when I click, my wizard comes up. And again, I have to select the variable. Okay, so it needs to be a quantitative variable because we're performing calculations. So I'm going to double click on the data set, ages. And then probably the most important step that a lot of you will forget is that you need to tell it what statistics to calculate. So I'm going to click on the Statistics widget button at the bottom of the wizard screen, and it pops up. And I'm going to mark off, and I have the list on the PowerPoint, but you want the mean, the standard deviation, the variance. If something is checked, say for example, SE or standard error of the mean is checked and you don't want it, you just click on it and uncheck it. If there's something that you want that's not checked, say for example, as we go through the list, mode, we want standard deviation, variance, first quartile, median, third quartile, interquartile. We also want the mode, but it's not currently checked. So I would just click and it checks it. Then in the second column, you want the minimum, the maximum, and the range. In the third column, you want N total. How many did you have total in your sample? And then it says check statistics, and it's set at the default. Just leave it as the default. So once you've selected all of the things that you would like Minitab to calculate, you click OK. Click OK again, and it automatically calculates all of those statistics for you. So then it gives you this output, and again, I have the output on the PowerPoint slide here. Total count would be your sample size. It gives you your sample mean, the standard deviation, the variance, the minimum, quartile 1, the median, quartile 3, maximum, the range, the interquartile range, and the mode. This last thing where it says N for mode, that's telling you how many times the mode occurred. So for this particular data set, there were 16 students who were 19 years old. Okay, so we have all of this, and then basically you're going to record this in kind of in a table. You could, copy and paste this. If you were pasting it into a Word document, you can copy and paste. So, okay, we've got all our numbers. What now? So now we can answer the original research question. What is the average age in years of students taking classes on the GHC Cartersville campus in 2018? For our sample of 50 randomly selected students, the sample mean is approximately 23 years of age. Therefore, we can infer that the average age of all students taking classes on the GHC Cartersville campus in 2018 is 23 years old. Remember, that's kind of the connection between descriptive statistics and inferential statistics. We take what we've learned about our sample of 50 randomly selected students and we infer it or apply it back to all the students or to the entire population. We can also verify that our distribution is skewed to the right by comparing the mean, the median, and the mode. The mean was 23, the median was 19, and the mode was also 19. So 19 is less than or equal to 19 is less than or equal to 23. So we can now definitely say without a doubt that our distribution is skewed to the right. We can also begin to think about, does our data set have any outliers? Okay, using the formula that any data value that's less than or is less than Q1 or quartile 1 minus 1.5 times the IQR, or any data value that is greater than Q3 plus 1.5 IQR. And I've worked through those numbers here for you. On the lower end, we would have to be any data value less than 11.5, and we didn't have any ages lower than that. On the upper end, any data value that's greater than 31.5 years. And so we did have a few of those. We had a student that was 32, 34, 44, 49, and 54. So there were actually 5 outliers in this particular data set. So we can do that algebraically. The other important piece that comes out of this that you're often asked to provide when you're conducting research is the 5-number summary. The 5-number summary includes the 5 statistics: the minimum, the first quartile, the median, the third quartile, and the maximum. Now, all 5 of those you've already calculated when you calculated these descriptive statistics. Okay, you get the minimum, quartile 1, the median, quartile 3, and the maximum. In fact, they're kind of all aligned together, so all 5 of them are kind of in the middle of your output or your results. Okay, but we can also visualize that 5-number summary on a graph called a box plot. And this was the other type graph that we had discussed previously and looked at how to kind of sketch it roughly by hand. But again, this one gives you some insight, a little bit more insight than the histogram or the stem and leaf. So I do have the instructions there on the slide how to create the box plot in Minitab. But again, I want to walk you through it. So again, we've entered our data. You always got to start with data, guys. And we want to create a graph. So at the top menu bar, I'm going to choose Graph. And I want to create a box plot. Sometimes it's called a box and whisker plot, but Minitab calls it a box plot. Again, there are various types that we could create if we needed to compare different groups. It defaults to simple. We're going to keep it simple. So I tell it OK. Again, you have to select the variable. It does have to be a quantitative variable, so I'm going to choose ages. And again, you want to include your labels. You want to make sure that you have a title. And so again, we might say ages of students, GHC, Cartersville campus, spring 2018. And I click OK. I click OK. And it creates for me a box plot. Now notice you have these 5 star looking things on the box plot, which I've copied onto the PowerPoint. Okay, those little stars are the outliers, which we indicated algebraically there were 5. So we have 5 little stars. Again, we should pay attention to the scale. The vertical scale represents the ages. It looks like it started at 15 and they're counting by 5s. Notice how this box, the blue box here, is on the lower end. Typically when it's on the low end, that is an indication that our data set is skewed to the right, which we've already confirmed that our distribution is skewed to the right. And regardless of whether you're looking at the box plot or the stem and leaf or the histogram, they all should have the same distribution because we're talking about the same data set. Okay, you have kind of this first line here of the blue box represents quartile 1. The other side of the box is quartile 3. In this particular example, quartile 1 and the median were the same value of 19. So you don't have, sometimes you might see an extra line in the middle of this box, which represents your median. But in this particular example, our median and quartile 1 were the same value. And again, I can immediately, with the box plot, the biggest benefit of the box plot to me is I can immediately see, oh, I've got some outliers because I have the stars. And guys, you can have outliers at the high end, as we do here, or at the low end, and it's possible you could have them at both, depending upon your particular data set. Okay, so that kind of concludes this video and the walkthrough of how to use Minitab to find your descriptive statistics as well as to create a box plot.